All right, let's look at a couple of these gas properties with this PhET sim. I click on ideal, and then I'm going to say hold constant nothing. I'm going to put a pump full of particles inside the chamber. And now I have a whole bunch of opportunities here. I'm going to say I'm going to keep the temperature constant. I'm going to move my container and measure the width. So this is actually a cube. So if you double this, you're doubling the volume. Okay. So here we have a width or a volume basically of 5. And our pressure looks like it's probably just a little less than 12. So maybe 11.8. So, what do you think is going to happen to the pressure if I increase the volume of the container? Well, let's try it. I will double the volume of the container. If I can get it out there. There we go. Now, doubling the volume of the container, it's now 10 wide. And our pressure has dropped. I love how it bounces around like that. Somewhere maybe 5.7? 5.8? I don't know. Somewhere in there. Okay. So, once again, let's increase our volume, and now I'll do it to 15. That's as far as it goes. So at 15, what is our pressure? That looks like it's somewhere right around 4, maybe? Okay. So if you look at 5, the pressure was around 12. Doubled the volume, and the pressure fell to around 6. So we doubled the volume, pressure fell by 1/2. We went from 5 to 15, we tripled the volume, and our pressure went from 12 to about 4. So our pressure went down by 1/3. Pressure and volume are inversely related. Okay, let's redo this. And let's put another, I wonder if I put 2 squirts in there. I wonder if that helps the pressure even out any. Okay, so now let's keep the volume constant, okay? All right, so our pressure is, no, it doesn't seems to bounce around just as much, but kind of looks like maybe 10.8. All right, so we are at 300 K. What if I lower the temperature by 1/2? Whoop. Okay, I have lowered the temperature by 1/2, and my pressure has pretty much lowered by 1/2. So that's maybe 5.3. So our initial pressure was 10.8. Our final pressure was 5.3, about half. And so if we lowered the temperature by 1/2, we lowered the pressure by 1/2. Pressure and temperature are directly proportional. Okay, let's see now. Let's rewind. Put a couple of scoops in here. Put our width back up. Now, I'm trying to remember which one is which. Let's move our volume down to 5 again. And now if I do that, here's my pressure, 22.2 atmospheres. And 300 K is my temperature. Okay, so what if I heat this up to, let's say, so I've doubled my temperature in K. So I'm now up to 600 K. My pressure has been kept constant. What is my volume? Looks like it is twice what I started with. So if I double the temperature, I also double the volume. This is telling me that volume and temperature are directly proportional.